In the vast darkness of our galaxy, astronomers have found a star that shouldn't even exist. They call it the Methuselah star. And if its discovery wasn't weird enough, scientists estimate it to be 14.5 billion years old, which makes it at least 600 million years older than our universe itself, which is 13.8 billion years old. So how could something be older than space and time? The answer, scientists say, may lie in the very beginning of the universe, before the Big Bang. There are many theories that attempt to explain the origin of our universe. But in order to understand those theories and how this ancient star might relate to them, we first need to get a basic understanding of the Big Bang theory and how we know that our universe is 13.8 billion years old. The Big Bang theory explains how our universe began with a small, hot, dense singularity, like a tiny ball containing all matter and energy. Then, roughly 13.8 billion years ago, it rapidly expanded, cooling as it did so, eventually leading to the formation of galaxies, stars, and planets. We know that the universe is 13.8 billion years old because scientists have managed to observe the cosmic microwave background, a faint glow that permeates the entire universe and which they believe was released when the universe was just 400,000 years old. By studying the wavelengths of this light, astronomers were able to calculate how much the light had stretched as the universe expanded. Basically, they were able to determine how fast the universe was expanding and then rewind that rate to arrive at an age for the universe. But if the universe started with the Big Bang and we know how old it is, how could there possibly be a star older than the universe? Well, in the early 1960s, two astronomers named Fred Hoyle and William Fowler proposed what they called the steady-state theory. This model suggested that the universe never had a beginning and therefore has no age. Instead, it always existed and always would. According to this theory, the universe was infinite in both size and age. However, as technology improved, observations disproved the steady-state theory. For example, in the late 1960s, radio telescopes revealed that galaxies were moving away from each other at speeds proportional to their distances. This observation led to the conclusion that the universe was expanding, which meant it had to have a beginning, but some astronomers still wondered if maybe there was something wrong with the Big Bang theory. Enter Arno Penzias and Robert Wilson. In 1978, they discovered the cosmic microwave background, providing strong evidence in favor of the Big Bang. As such, the Big Bang theory became the prevailing cosmological model, and most astronomers rejected the steady-state model. However, recently, interest in the steady-state theory has been renewed thanks to several mysterious observations, including the behavior of galaxies and the accelerating expansion of the universe. According to the Big Bang theory, galaxies should get brighter as they move away from us, but astronomers have observed that some appear to be dimmer than expected. One explanation is that these galaxies are experiencing an accelerating expansion in a way that violates the laws of physics as we understand them. But another explanation is that the universe actually is infinite in size and age, which means that there are multiple instances of the same galaxy located at different points throughout the cosmos. Then there's the strange issue with dark energy, a hypothetical substance that scientists believe makes up around 3/4 of the universe. Its presence seems to be causing the expansion of the universe to accelerate. But here's the thing. According to Einstein's equations, dark energy should have caused the universe to expand faster and faster since the Big Bang. Yet observations suggest that its effects only became significant around 4 billion years after the Big Bang. One possible explanation is that dark energy didn't exist until roughly 4 billion years after the Big Bang. And if that's true, then perhaps the universe really does have an age, meaning that it could have existed in a different form prior to the Big Bang. And that brings us back to Methuselah star. Some astronomers believe that it formed from material that existed before the Big Bang. That would mean that the universe as we know it today formed out of matter that was somehow recycled from a previous universe. Now, this idea might sound crazy, but it's not entirely without precedent. You see, according to quantum mechanics, empty space isn't really empty. It's filled with fleeting particles that spontaneously pop in and out of existence. This phenomenon is known as quantum fluctuation, and although the fluctuations are temporary, They're real. In fact, these particles can interact with each other, forming larger particles, including antimatter. Now, if the universe really did have a beginning with the Big Bang, then all the matter in it likely started out as a hot, dense soup of subatomic particles. But what if the Big Bang didn't cause the creation of the universe but instead the creation of matter? What if the universe had always existed in a state of quantum fluctuation? Then all the matter in the universe could have originated from pairs of fleeting particles that popped into existence and then annihilated each other. If this were true, then the universe could have had multiple instances of galaxies, stars, and planets that existed before the Big Bang, and perhaps Methuselah's star was one of them. But there's another possibility. You see, while the universe has only been around for 13.8 billion years, that doesn't necessarily mean that 13.8 billion years is all the time that has passed. According to Albert Einstein's theory of special relativity, time is relative. This means that time is not universal. In other words, time passes differently for different observers depending on their relative motion. Imagine, for example, that there were two observers, one standing still and one moving near the speed of light. For the observer standing still, time would pass normally. But for the observer moving near the speed of light, time would appear to pass more slowly. So if an astronaut were to travel close to the speed of light for a year and then return to Earth, they would find that less than a year had passed for their loved ones. To them, time would have almost stopped. Because of this, there's no reason why the passage of time couldn't be different for distant stars. Perhaps Methuselah's star is actually only 13.8 billion years old. But because it's located far away from Earth, it appears to be much older. And fortunately for now, there's no way to test this theory. But regardless of the actual explanation for Methuselah's star's age, one thing is certain: it's an enigma that challenges our understanding of the universe, and serves as a reminder of how much we don't know about the cosmos. And who knows, maybe one day we will discover other relics from a forgotten universe. Until then, Methuselah's star remains a beacon of mystery in the night sky. If you enjoyed this video, be sure to check out my previous content, and thank you for watching.